The annual maximum recorded floods of a river are given. The Gumbel extreme value distribution fits the recorded data. Estimate the flood discharge with recurrence interval of 5, 10, 50, 100 and 150 years. Since the data follows Gumbel extreme value distribution, we will use a set of equations associated with this distribution to obtain the value of maximum flood. Now, Gumbel's distribution is widely used for probability distribution of extreme value in hydrologic studies for prediction of flood peaks, maximum rainfall, etc. And these are the equations associated with the Gumbel distribution. We'll follow this procedure step by step to obtain the required xt, which is the maximum flood corresponding to recurrence interval of 5 years, 10 years, 50 years, 100 years and 150 years. Find the mean and standard deviation of the discharge data. Okay. First of all, n is 27 years, 1992 2016. So n is 27 years. Mean, average of these values, standard deviation can be easily obtained using this stdv.s. Okay, so the mean and standard deviation have been obtained. Now determine the reduced mean yn and reduced standard deviation Sn using tables. Okay, so we'll find out yn and Sn, which will be required in this equation to find the frequency factor. So they can be found out from the tables. Now the value of yn corresponding to the given sample size of 27 is 0.5332, and value of reduced standard deviation corresponding to sample size of 27 is 1.1004. Okay, now find the reduced variate for a given recurrence interval using this equation. Yt is equal to minus ln t by t minus 1. So Yt is equal to minus ln natural logarithm ln bracket t, 5 divided by 5 minus 1. Okay, the value of Yt, reduced variate, has been obtained. Now find frequency factor k using this equation. K is equal to Yt minus yn divided by Sn. I'll anchor these values so that they don't change. Okay, the value of frequency factor k has been obtained. Now the value of xt, maximum flood corresponding to recurrence interval of 5 years, can be obtained using this equation. Okay, xt is equal to x bar, which is the mean. I'll anchor this cell, plus k, frequency factor k, multiplied by standard deviation 1430. Okay, so the value of maximum flood has been obtained. It is 5531 meter cube per second. Similarly, we can find out yt for 10 years, 50 years, 100 years and 150 years. Corresponding frequency factor k can be found out using this equation, and then the value of xt can be found out using this equation. So this is the maximum discharge corresponding to recurrence interval of 150 years. It is 10,089 meter cube per second. It is 6,506 meter cube per second for recurrence interval of 10 years, 8,652 for 50 years, 9,560 for recurrence interval of 100 years. So now these values can be plotted on Gumbel's probability paper, and Gumbel's probability paper uses these values on its x-axis, reduced variate y, recurrence interval t, probability, and this Gumbel's probability paper would look something like this. Here is the reduced variate, here is the corresponding recurrence interval, and on the x-axis there is frequency or probability equal to 1 by t. So we have the value of t, y and frequency or probability on the x-axis, and value of annual peak flood on the y-axis. So if these values are plotted, it will give a straight line, and from this graph value of recurrence interval corresponding to any annual peak flood value can be obtained easily. Xt is on the y-axis, xt is the maximum flood value, and yt will be on the x-axis. Okay, so will give us a straight line, and corresponding t can be obtained using the equation to using this equation. T is equal to 1 divided by 1 minus e raised to minus y. We already know the value of t corresponding to the value of yt, 5, 10, 50, 100, 150. And you can use this graph to obtain the value of corresponding time interval for any value of Q or discharge. So using Gumbel's extreme value distribution, we have obtained the values of flood discharge corresponding to 5, 10, 50, 100 and 150 years of recurrence interval.